I've heard that crystallography, it kind of has this reverence from other biologists that like it's a special kind of art form basically. And I've
Yes.
even heard like that certain crystallographers, they only play like classical music when they're in the lab because there needs to be this, you
Yeah.
know, like perfect condition for the crystals to form. So can you talk about that? Did you have any like
Yes.
quirky crystallographers you worked with?
Oh, yes, absolutely. It's an interesting field. I mean, there's definitely like a little bit of what I would call voodoo or black magic surrounding this field. I've definitely heard of crystallographers who only use like this very specific horsetail hair to start seeding their crystallization conditions, and they swear by like this one cat whisker or something like this. I mean, like, to be fair, like animal hair is used as kind of like a nucleation initiator for crystallization sometimes. So it is like an actual technique to you know mostly use a solution that has like formed maybe microcrystals to initiate seeding of larger crystals with like animal hair or other things that can like provide a nucleation basis or something like this. And but yeah, it's just, since we don't really know a priori what type of conditions a protein will crystallize in, if ever, um, everybody kind of like has their own secret sauce, and depending on what type of conditions have proven to be successful for you in the past, you kind of get a little bit attached to them. And so I would say that process it's systematic. I wouldn't necessarily say it's scientific.
I love that.
So my grad school protein was a heterodimer, and it was like and there was no covalent cross-link that would kind of like staple these two subunits together. So it was actually quite challenging to produce a predominantly heterodimeric solution. And I used a lot of native's mass spec to quantify how much homodimer of the two homodimer types do I have in solution, and how much heterodimer do I actually have. And so my main contribution to this field as a graduate student was actually the crystal structure of a heterodimer of the catalytic subunit of the wild type human protein of this cardiovascular disease drug target, but I could never reproduce those crystal conditions. Even with the same protein prep and like the same crystallization buffers, all I got were heterodimeric homodimeric crystals instead of like the heterodimer crystal. But like the heterodimer crystal that I got crystallized to, or like diffracted to 1.9 angstrom resolution, and I got a beautiful data set. And there are, tenth of thousands of refractions that point towards your model being correct. And so I had lots of philosophical discussions with friends during grad school whether this was science, because I couldn't reproduce what I had done, even though I had a giant data set that kind of like was consistent in itself. It's a little
Wow.
bit of like a dark art, and
Yeah.
you can definitely like crystallography is kind of like an interesting case when it comes to science reproducibility, because like nobody would probably argue with me that like the data point that I got in this crystal structure was not like an important scientific piece of data. And obviously like I published my work and like I deposited the structure because it was a contribution to the field. But other people who are talking a lot about reproducibility are saying like, well, it's not really science if you can't repeat it. But it really breaks down in like the field of crystallography a little bit.
Like I feel like we could talk for hours, but you probably have things to do.
This was really lovely. Thank you so much for having me. This was super fun.
Yeah, it was super fun.